Okay, in this video, we're going to solve this problem right here, and so let's begin. So first, what I recommend is to do a simple plug-in, so let's do that. So x is approaching 0, so if I put a 0 here, sine 0 is also 0, so 0 minus 0. Again, I'm putting a 0, and tan 0 is also 0. And so what we have is 0 over 0. And so that's a red flag that we can go ahead and use L'Hopital's rule. And so with L'Hopital's rule, we're going to take the derivative of our numerator, and we'll take the derivative of our denominator. So we have the limit as x approaches 0, parentheses, d, derivative for the numerator, x minus sine, parentheses, x, close it, divided by derivative of our denominator, x minus tan, parentheses, x, close it, and the whole thing we close. So at this point, we take the derivative of the numerator and the denominator. The derivative of x is just 1, minus, and the derivative of sine would be cosine. So minus cosine, parentheses, x, close parentheses, divided by, again, the derivative of x is 1, minus the derivative of tan x is secant squared x, so we get minus secant squared x, close parentheses. So we plug in a 0 for cosine. Cosine 0 is 1. We get 1 minus 1, which is 0, divided by secant 0 is also going to give us 1. 1 squared is 1, so we get 1 minus 1, which is also 0. We have 0 over 0, which is a red flag that we can go ahead and use L'Hopital's rule again. So is equal to limit as x approaches 0, parentheses, we take the derivative of our numerator, which is 1 minus cosine, parentheses, x, close parentheses, divided by the derivative of our denominator, which is 1 minus secant squared, parentheses, x, close parentheses. And the derivative of 1 is just 0, and the derivative of cosine is negative sine. But we also have a negative here, so a negative gives you a positive, so we get sine parentheses x divided by, again, the derivative of 1 is just 0. And now in this piece, we have to go ahead and use the chain rule. So we're going to get negative 2 secant parentheses x times, we'll take the derivative of secant x. So we'll say d parentheses secant parentheses x. Okay, let's clean it up. So we have the limit as x approaches 0. Again, the numerator stays, so we have sine parentheses x divided by, we have negative 2 secant parentheses x times, the derivative of secant x is going to give us secant x tan x. So we'll put secant x times tan parentheses x, close parentheses. Okay, we can clean up again, so we'll have the limit as x approaches 0. Again, the numerator we have sine parentheses x, denominator secant x times secant x, so that's secant squared x. So we have negative 2 secant squared parentheses x times tan parentheses x, close parentheses. Okay, so let's rewrite it again. Limit as x is approaching 0. We have sine parentheses x divided by negative 2 secant squared x. Now instead of tan x, we know tan x is sine x divided by cosine x. So we could say times sine x divided by cosine x, so cosine x would be in the numerator. Cosine parentheses x, close parentheses. By doing this, sine x cancels out, and we have to remember secant squared x is 1 over cosine squared x. So instead, we can write what we have as limit as x approaches 0 for negative 1/2 times cosine cubed x, close parentheses, because this cosine squared x is going to go to the numerator. Cosine squared x times cosine x is cosine cubed x, and we have 1 divided by negative 2. And so our last step is just plug in 0, and so we're going to get negative 1/2 times cosine cubed 0, and cosine 0 is just 1, and so this is going to give us negative 1/2. And this right here is our final answer, and that's all we need to do for this problem.